almost time for my next meal, and here it is, one hamburger patty. All I need to do is to pop it in the microwave and leave it there for a few minutes. Well, that's a microwave oven, but how does it work? What are microwaves? Well, they're actually electromagnetic waves. That's not much help to you yet, is it? Electromagnetic waves are all around us, but most of them we can't see. Some of them, however, we can see. Ordinary light. Light that comes from the sun, light that comes from lamps in the ceiling. We can see those kinds of electromagnetic waves. Have a look at this. I have a very bright light over here, and I'm going to shine it onto some of these crystal ornaments. There we are there. Now, ordinary light we call white light. When it hits a little crystal ornament like this, look what happens to it. It breaks up into a whole multitude of colours. If you look at those colours, you find something that's very pretty and also interesting. You'll notice that the white light has been broken up into the colours of the rainbow. Red, orange, yellow, green, blue, indigo, violet. Right? Those are the colours that you know well from looking at a rainbow in the sky. That's just one form of electromagnetic radiation or electromagnetic waves, but there are many other kinds beyond the red and beyond the violet or purple at the other end. Beyond the violet or purple, there are invisible waves called ultraviolet waves. What do you know about those? Quite right, they're the ones that you have to be careful of on sunny days. You can't see them, but they're the ones that give you sunburn. Also, way out there on the violet end, waves that you can't see include things like X-rays, the kind that you can pass through yourself with a special machine and see bones and all sorts of internal structures. Maybe you've had an X-ray taken at a hospital or at the doctor's surgery. What about the other end, down the red end? Well, there you have the radio and the television waves, the sorts of waves that bring messages into your transistor radio at home or into your television set right now from a distant source. Also, out there beyond the red are the microwaves. Now, the microwaves cause food to cook. Let's think about normal cooking. If you take a saucepan and put it on a stove, what happens? Heat comes from underneath the saucepan, from the gas or electricity, and a lot of the heat is actually lost. Why is the heat lost? Well, because there's air all around the saucepan and some of the heat goes straight into the air. Some of the heat goes to heat up the saucepan itself and the water that's in the saucepan and so on. Only a small amount gets into the food. What about when you cook something in a normal oven? Once again, you end up heating a lot of air, you end up heating the oven itself, and it's relatively slow. But with microwave cooking, something very different occurs. The microwaves penetrate the food itself. Now, when I've been talking about waves, perhaps you've been thinking about waves at the beach, and you know that it may take seconds for waves to come in. Maybe if you're lucky, you might get 4 or 5 waves coming in per minute. If you take a piece of rope, you can manufacture waves that move more rapidly than that, can't you? Maybe 4 or 5 per second if you wiggle the rope backwards and forwards rapidly. Well, these invisible microwaves that we're talking about here in the oven, they can actually vibrate backwards and forwards more than 2,000 million times every second. And it's those vibrating waves that cause the molecules of water in the food to vibrate. And when things vibrate, you get friction and there's a heating effect. And that's what's happening in the food. Let's look inside the microwave oven. Here's one that you've never seen before. The outer case has been removed and you can see all sorts of electronic wizardry inside here. There's a transformer, there are other things. Here's the important thing, that's called a magnetron, and that's the gadget that's producing the microwaves. There's also something up here which is quite simple. Maybe it looks like something on your bicycle, and in fact it is. It's a bell that tells you when the food's ready. The magnetron itself is an interesting gadget. There it is there. And it's that produces the microwaves. Now, it's not producing any at present. If it were, I wouldn't be holding it because the microwaves can be damaging, of course. When microwaves are sent out in pulses, that's how radar is formed. And you know about radar and the radar police traps that catch your speeding car. Similar sort of waves. Well, if we come back to our microwave oven, let's see what's happened to the microwaves penetrating the hamburger patty. Aha, just how I like it. Well done. And while I'm eating this, I have something else for you to watch. Not food this time, but 3 pieces of glass with lots and lots of tiny little globes on them, and they're very special globes. They only light up when they're hit by microwaves. Right now they're not alight, no microwaves around here. I'll put them in here, set the oven going, and you watch through the window. Look at that. Orange lights, green lights, all showing you where the microwaves are. They're flashing on and off because the microwaves are penetrating the globes, then they're missing a few microwaves, and they pick up some more, and so on. And you can see from that there's an even distribution of microwaves right through that oven. That's why it cooks my food so well.